Hello everyone. Here in this video, we shall discuss the second topic of the vector space, that is called subspace. So what is mean by subspace? So consider a set, say S subset of V, where V is a vector space. So a non-empty set S subset of vector space V is called subspace. Is called subspace if it is also vector space, if it is also vector space under the same operation as in V. If what S is also a vector space, S is also a vector space under same operation, under same operation as that of vector space V. So what does it mean? What we have to check if the set is to be proved as a subspace. So in short, or in other words, what we can say that S is subspace. S is subspace of V if we'll take three conditions. What are the three conditions? That S should be non-empty. S should be non-empty. That is, for this we just show that 0 belongs to S. Then second, if we take any two elements, take any two elements of a S, then their vector addition also belongs to S. And the third condition is if alpha is a scalar, that is a number. So here we restrict ourselves to a real number. The number can be complex also. But under this topic, we are restricting the values of alpha as a real number. And U belongs to the set S. Then this implies alpha into U, which is a scalar multiplication, also belongs to S. So if these three conditions are verified, then we say that a given set S is a subspace of V. So the very trivial subspace are singleton set 0 and the given vector space itself, that is singleton set 0 and V are the trivial subspace because they verify the given condition by default. That's why it is called the trivial subspace. So we can show this easily. Let us take, suppose I am taking singleton set 0. So as per our notation, S is nothing but singleton set 0. So clearly here you can see that 0 belongs to S. That's why S is a non-empty as per condition. Again we know that 0 plus 0 is nothing but 0. So this condition of vector addition also gets satisfied. Again, if I'll multiply 0 by some number alpha, then this is also the element of S because alpha into 0 is equal to 0 and it belongs to S. So in this way, all the three conditions are verified. Therefore, singleton set 0 is a subspace of vector space V. And this is the smallest subspace of any given vector space. Now, let us see some example. So, as we know that in order to check a given set as a subspace, we have to verify these three conditions. So, let us see one example. First example on subspace. So, what it is given that prove that the subset the subset is here denoted by W is equal to. Now what it contains? It contains element x1, x2, x3, that is triplets. Triplets which are definitely element of R cube. And what is the condition? Condition given is x1 plus x2 plus x3 equal to 0. So this is a subspace of R cube. This is what we have to prove here. So whenever a set is given, so you should first understand what exactly is given or what are the conditions for being a member of a given set. So it is given that W is this. So I can write from equation 1 what type of element will belongs to W. So first of all, it should be in the form of triplets. So 1 implies, I can write this in other way like this, that it it contains what type of element? It contains triplets. So triplets will be the element of W. When it will be the element of W? If it will satisfy the condition that x1 plus x2 plus x3 equal to 0. It means the addition of all elements of the triplets, when it comes out to be 0, then it will be called as a member of W. So this definition we are going to use in order to prove that any element belongs to W. So let us verify the first condition. Now what we have to prove as per the first condition, that is 0 elements belongs to W. Now what is a 0 element of a triplet? So 0 element of a triplet is all 3 elements 0. So clearly 0, 0, 0 belongs to W. Now why it belongs to W? Because if we add all these 3 elements, 0 plus 0 plus 0, it will come out to be 0. So this condition is get satisfied. So what this says, any elements belongs to W if their sum comes out to be 0. So therefore 0, 0, 0 belongs to W, right? So that is, we write it as a big 0 belongs to W. So W is non-empty, right? Now let's verify second condition. For a second condition, what we know, what we want, the requirement is U plus V belongs to S if I take any two elements of S, right? Here I have to select first any two elements of S at this set W. So the elements of W are in the form of triplets. So let us take, suppose I am taking first element as U, which is a triplet. Say it is of the form x1, x2, x3, and another element will select which is y1, y2, y3. So these are the two elements of W. What is that? U and V. What is our aim? Our aim is to show that U plus V belongs to W. Now, so for this, first of all, we will obtain what is U plus W, U plus V. So U plus V. So U is, as per notation, it's triplet x1, x2, x3. V is y1, y2, y3. This is what we have. Okay. Now, so how to add two triplets? So two triplets are added by adding their corresponding elements. It means we will add first element with the first one, that is x1 plus y1. Second with the second, so x2 plus y2. And third with the third, so x3 plus y3, as per addition of two vector quantity. So this is what we have. Now you can observe here, my first element of this U plus V is x1 plus y1. Second element is this, and obviously third element is x3 plus y3. Now we wish to show that U plus V belongs to W. For this, as per the equation 2, what we have to show, that addition of all three elements of this particular vector or element must be what? It should be 0. So for this, we will consider the addition of x1 first element, that is x1 plus y1 is my first element. Second element is x2 plus y2. Then third element is x3 plus y3. So this addition we are considering here, and resultantly we want it as 0. Now what will be addition of this? So we can write it as like this. Bring all x terms together. So we will write x1 plus x2 plus x3, then plus y1 plus y2 plus y3. Now you can see as u belongs to x1, x2, x3 and v belongs to y1, y2, y3. So as per condition, as these are elements of W, so what we have here, you can see that x1 plus x2 plus x3 must be 0, right? Because of definition of W, this condition, equation 2. Again, V is element of W, so addition of all three elements of the triplet must be 0. So we can call this equation so obtained as 3. So this is what we will be using here in this. So the value of this is 0. Again y1 plus y2 plus y3 is 0 because of equation number 3. And we know that 0 plus 0 is 0. So what I am having now, addition of all three elements of this u plus v is a 0. So therefore, as per the definition of W, what will be the conclusion? That u plus v belongs to W. So second condition is verified. Let's have third condition. So for this, we need to first find out alpha u. So alpha is any scalar quantity and u, as per the selection which we have taken here, is x1, x2, x3. Here it is x1, x2, x3. Okay. Now, how to multiply any vector quantity with a number? That is multiplying each component of the vector by that scalar. So it is alpha x1, alpha x2 and alpha x3. This is what I am having as alpha u. Now again, what we wish to show? We wish to show alpha u belongs to W. So for this, condition of W should get satisfied. What is the condition? Addition of all these three elements. Addition of all these three elements of a alpha u must be 0. So we will consider its value. Let us try to evaluate its value. So consider alpha x1 plus alpha x2 plus alpha x3. Now this you can write as, you can take alpha common and we can write it as x1 plus x2 plus x3. And as per equation number 3, we know that value of x1 plus x2 plus x3 is nothing but 0 since equation 3. So this comes out to be 0. So as addition of three components of this vector quantity alpha u is 0, therefore conclusion will be alpha u belongs to W. So just recall what we have shown, that 0 belongs to W, then u plus v belongs to W. Whenever u and v are elements of W, then alpha u belongs to W if alpha is a scalar and u is a element of W. So from these three, conclusion could be that W is a subspace of R cube as all the three conditions are satisfied. So I hope this is clear to everyone. We shall see few more examples in the next class. Thank you for watching the video.